Okay, example 3, we're now going to find the nth term formula for a sequence where all of the term values are fractions. Now, what you need to do is break up each fraction into a sequence of numerators and a sequence of denominators. So what we're going to do first is get the nth term formula for all of the numerators. So we're going to put a little title down, nth term for the numerators So we're going to write down the term value of each numerator. So we've got 4, 5, 6, and we've got 7. And then we'll just label those. Those are the term values. And that's UN for short. Above the term values, we're going to write down the term numbers. So 4, that's the first term. 5 is the second term, 6 is the third term, and 7 is the fourth term. So those are our term numbers n. Now, you'll notice that the term values for the numerators are a linear sequence. They're going up by the same amount each time. We're adding on 1, adding on 1, and adding on another 1. So what the sequence goes up or down by each time, again, is called the common difference. And now we can begin to write down the nth term formula for the numerators. So remember, our formula begins with UN. And then the common difference gives us the coefficient of n. So UN is going to equal to 1n. And then we have to check, does this formula work? Does it correctly take each term number n and transform it into its term value un? So let's start by subbing in n as 1. So when we sub in n as 1, we're going to get 1 times 1 is going to give us 1, but we should be getting 4. So how do we turn 1 into 4? We've got to modify it and add on 3. Now let's check, does it work? So when we sub in n as 1, 1 times 1 is 1, plus 3 gives us 4. When we sub in n as 2, 1 times 2 is 2, plus 3 is 5. When we sub in n as 3, 1 times 3 is 3, plus 3 is 6. When we sub in 4, 1 times 4 is 4, plus 3 is 7. So we've now got the nth term formula for the numerator. Now what we're going to do is go back to the original sequence and we're going to get the nth term formula for the denominators. So again, we put another little title down, nth term for denominators. And again, we write out all the term values of the denominators. So we've got 3, 5, 7, and 9. Again, label those. Those are the term values. And then again, above each term value, we write down the term number. So 3 is the first term, 5 is the second term, 7 is the third term, and 9 is the fourth term. And we label the top numbers the term numbers, n. So again, what we have here is a linear sequence because all the term values of each denominator is going up by the same amount each time. So we're adding on 2. To get from 3 to 5, add on 2. We add on another 2. And then we're adding on another 2. So plus 2 is the common difference this time. So again, we have to get our nth term formula that connects each term number to its term value, and it always starts with un equals. And remember, the common difference tells you what the coefficient of n is in the formula. So the coefficient of n is going to be 2, and then we write down n immediately after. So this is the starting point for our formula. Let's check to see if it works. Does it work with 1, and does it turn it into 3? So let's sub in n as 1. 2 times 1 is 2, but we actually want the answer to be 3. So how do we get from 2 to 3? We've got to add on 1. Now check it again. So when you sub in n as 1, 2 times 1 is 2, plus 1 gives you 3. Does it work when you sub in n as 2? 2 times 2 is 4, plus 1 gives you 5. Does it work when you sub in 3? 2 times 3 is 6, plus 1 gives you 7. Does it work when you sub in n as 4? 2 times 4 is 8, plus 1 gives you 9. So it works. So far, we have worked out the nth term formula for the numerators. We've worked out the nth term formula for the denominators. Now we're going to work out the nth term for the overall original sequence. So, final little title is the overall nth term. So again, it starts with un, and because each term in the original sequence, each term value in the original sequence is a fraction, that means the nth term formula is going to be a fraction. So I'm going to put my little fraction line in. Now, the numerator for our overall nth term formula will be the nth term formula that we came up with for the numerator. So it's just 1n plus 3. And then the nth term formula here for the denominator will be the nth term formula we come up with for the denominator. So it's just 2n plus 1. So, and what we have here is the overall nth term formula for the original sequence of term values. So because the original sequence consists of fractions, that means the nth term formula will be a fraction itself.